So let's see if we have enough people coming on board. So we'll just wait a few seconds here, so a few people, they come on. You can see the attendees is starting to trickle in now. Okay, anyway, I'll kick off now because this webinar is recorded. We have 9 presenters, so it will be the full hour today. So any latecomers, they can probably go back and view it on YouTube later then, yeah. So, and I'm sure that all the attendees and everyone are really more interested in the actual presenters rather than me. So TLA Robotics, it's a voluntary group that was started by myself in 2020 to promote British and European robotics companies. The reason was really that more than 80% of funding for robotics companies, especially with the hardware component, is located to North American companies. They get the bulk of all funding. So TLA is short for Tech London Advocates. This is a free networking group for students, professionals, and others with an interest in technology. If you want to join the group, simply send us an email. You've got the email on the screen, or check out our website as well. There are more than 20 working groups in Tech London Advocates, so TLA Robotics is one of those. So let me go. So TLA Robotics, we have 3 aims, pretty straightforward. We want to encourage increased investment into EU and UK robotics companies, especially those with a hardware component. We want to promote the take-up of robotics and automation and improve gender imbalance in the sector. So we currently have 6 group members. These are us. For all our attendees, please remember to take a screenshot when there's something interesting on the screen or an email address that you want to remember. After the presentation, we will try to answer a few questions as well, perhaps 5 or 10, depending. All attendees can post questions during the webinar as well. So, as I said, this webinar is recorded and will be available on our YouTube channel in a couple of days. So this particular webinar is sponsored by Style Intelligence. So Style Intelligence is a publisher of free market reports. We have background in M&A research. There are quite a few robotics reports. So if you want to go there and download, if you're interested in kind of Amazon robotics and so on, please do. And with that, I will stop sharing and hand over to Matthew Cornford at Ocado.
Thanks, Tom. Welcome, everyone. Let me just share my screen and I'll do my rapid introduction. Right, so Matthew Cornford, I'm head of product at Ocado Technology, looking after some of our robotics and automation development. So I think I've been given 5 to 10 minutes to whiz through these slides to give you a brief introduction to who we are and what we do. So Ocado Technology develops the cutting-edge technology that powers what we call the Ocado Smart Platform. This is a platform for end-to-end grocery e-commerce that we are selling to global retailers around the world, where they allow them to take their business online. And it's a full end-to-end platform combining everything from e-commerce, mobile apps, and websites, all the way through to robotics in our automated facilities. We are started as a UK-based company, been in the UK for just over 20 years now, but we have, in the last few years, rapidly spread around Europe and the world. We've got 10 development centers across Europe and North America. We have partners in 8 countries globally. We take some pride in our patents and protecting our IP, especially around our robotics and our warehousing as well. One of our very first robotic products that we really got into developing, like the entirety of hardware and software, is what we call the Hive. This is the system we kind of probably post the most videos about. It enables us to kind of claim to have one of the most highly automated warehousing in the world for kind of grocery e-commerce. It's a system of bots on a grid, kind of in the class of automation cube ASRS systems. And we develop all this in-house, the hardware, the software, the radio communication system. And it's a system which enables us to pick a 50-item grocery order in 5 minutes or less. So this is a little video we'd like to show. We like to simulate our system. This is one of our in-house simulations showing one of our grid systems running. Again, all developed in-house. This allows us to optimize our software, optimize our hardware, optimize our algorithms and our layouts with a much faster feedback and iteration loop than we would be able to without any simulation. So, like I said, our bots were one of the first pieces of robotics we really got into developing. There's some kind of cool stats about them on here. They whiz around at 4 meters a second. Every robot is identical, so we can easily swap them in, swap them out as necessary. And these robots generate a vast amount of data for us to analyze and use machine learning and AI kind of algorithms and models to improve our system overall. Benefit of developing in-house is we can generate all that telemetry, capture all that telemetry, analyze it ourselves and use that to our kind of advantage as well. Now, we've also been doing robotic manipulation for probably about 8 or 9 years. But given the nature of this, it has been something which has been in the research phase for much longer, and we're only really starting to productionize and commercialize our robotic manipulation kind of products. We have done some work in the past on the research front with EU Horizon 2020 products, two in particular, the soft hand manipulation SOMA project, which we are heavily involved in, and also the second hands project, kind of aiming to build a collaborative robot as well. We're really kind of proud of our involvement and work in those projects. You know, and they closed recently last year, and you know the organisers were genuinely impressed that these projects pushed on the field of robotics research and the state of the art in robotics as we know it today. On our road to productionization, we've made some kind of big investments recently at Ocado in robotics companies. So towards the tail end of last year, we announced we acquired Kindred Systems and Haddington Dynamics. We spent a long time scouring the robotics industry, looking for companies who had great products that aligned with our strategic aims and goals. We were really happy to kind of join with Kindred and Haddington and bring them as part of the Ocado group. And in the last couple of weeks, we've also announced a minority stake in Automata to extend our kind of strategic investment and look into the autonomous vehicle space. Obviously, as a grocery provider who also provides the last mile automation and other autonomous vehicles are going to be key to the future of robotics at Ocado. So that Ocado Technology in 10 minutes, probably the fastest presentation I've ever given on what we do at Ocado. So thank you for listening, and really look forward to all the other speakers to hear what other great robotics is going on in the UK. And thanks again, Tom, for inviting me along to let me speak today. I'll stop sharing my screen now.
Excellent. Thanks a lot for that, Matthew. Really interesting, really exciting stuff, even at 10 minutes. So over to Andrew at Foresight.
Thanks, Tom. My screen coming through now. My screen coming through now. I'm Andy Bloxham. I'm Andy Bloxham, a director in Foresight's private equity team, and picture there is the Shard in London, which is where Foresight Group is based. It's now FTSE listed, and I focus on the early stage funds. And the interesting thing about our early stage fund is that it's a joint venture between Williams Advanced Engineering and Foresight Group, and we have a focus on early stage hardware technology and industrial software. So robotics, industrial automation is a key area of focus for us. And we've partnered with an engineering organization to bring value add to the investments that we make. And The reason why that's important, as any of you will know if you've tried to raise funding for an early stage robotics company, many investors, early stage investors, might shy away from hard tech. They claim it takes longer to develop, it takes more money to develop, which is probably true, but equally, it makes it more defensible and potentially could deliver better investor returns for investors. And as long as you have an investor that understands the problems that an early stage hardware technology company might encounter, then that's an investor that's going to be willing to make a bet on those companies, which is what we do. So why are we comfortable with investing in early stage hardware companies like robotics? Foresight Group has been investing in early stage technology companies for a long time. Started in 1984, now has 6.8 billion under management. Most of that is actually in renewable energy infrastructure, but 700 million of that is in early stage SME investment. And we have a portfolio of over 100 companies, and we have a regional network of offices which we use, again, to work closely with those companies and to source new opportunities that we want to invest in. And we've partnered with Williams Advanced Engineering, which is the technology and engineering services division that was born out of the Williams F1 team so it started in 2010. Still based at the same campus in Oxfordshire, next to the F1 team, has over 300 staff covering a wide range of disciplines in engineering. And the picture there at the bottom, the Jaguar, it's one of my favorite WAE projects, which was the Bond villain's car in the film Spectre. When I saw that car chase through the streets of Rome, I actually thought it was probably an Italian supercar. I assumed it was probably a Ferrari, but it's actually a Jaguar. And it's a hybrid. So I think it had the range of a Nissan Leaf and an engine, internal combustion engine, that was similar in size to a Nissan Leaf, and the performance of the supercar. And it's a pretty exciting scene in Bond. And that sort of captures the way how the quality of engineering that Williams provide. I said it was born out of Williams F1. So these are the sort of capabilities that Williams Advanced Engineering was formed to provide in a consulting way. And they started with blue chips, but they were increasingly approached by startups wanting to benefit from the value that Williams could bring. And that's the premise of the fund. Foresight has a track record of investing in SMEs. Williams has proven technical expertise, and the combination is ideally placed to support early stage hardware robotics companies. So all the classic capabilities that you'd imagine it takes to run a successful F1 team: lightweighting materials, power systems, electronics, electrical mechanical engineering, defending good ideas, rapid prototyping, batch manufacturing, skills that are quite important to rapidly growing companies in hardware. And finally, the sweet spot of investment for us, typically seed to Series A, hardware, industrial software companies. That often means check sizes of about 500K to 2.5 million. And we're looking for growth opportunities. So we're targeting returns of 10 times on our initial investment. Primarily, we're looking to add value. So hopefully the founders of businesses are excited about Williams' involvement. Just potentially disruptive ideas that are unlocking new markets or new applications. A strong team that have ideally been there and done it before in some shape or form, or we'd look to introduce non-execs. And it can be pre-revenue, often is pre-revenue, but hopefully we can talk to potential customers and a large obtainable market. And if anybody fits that criteria or knows of other companies that fit that criteria, then please get in touch. Thanks very much.
Excellent. Thanks for that, Andrew. I'm pretty sure you'll get loads of contacts after this. So with that, we're moving over to Automata and Mustafa.
Yeah. Thanks, Thomas. Let me just share my screen. All good? All right, great. Thanks again for inviting me, Thomas. And since I only have 5 minutes, I thought I'll try to just kind of go over the learnings we've had here at Automata, launching a business in the automation space. So my name is Mustafa. I'm the co-founder and CEO here at Automata, where we work on this idea of accelerating automation. We used to talk about democratizing robotics, but we've recently shifted away from that language. And I think you'll see that theme quite a lot in the presentation today. So first off, what are we trying to work on? It's a very simple concept. It's a concept based on this idea that automation has been a technology that did not trickle down, right? It's designed for automotive, and in our opinion, it stayed in automotive. And the cobot market that we all see today is being a fundamental kind of reinvention of certain things to allow automation to enter new markets outside of that industry, specifically the long tail of manufacturing. And what this means for manufacturers today is the majority of manufacturing still looks like this, which is highly specialized lines and machines tended to by human operatives, right? And people who tend to do the same job day in and day out, not adding too much value to the use case, but it could be doing a much better job somewhere else, right? And again, it's because of this idea of the automation technology today has been designed for a very different kind of industry and a very different mindset of manufacturing that hasn't trickled down to other manufacturers. And this is the problem Automata was set up to solve. And over the last couple of years, we've been thinking a lot about how we do that. And that's why I want to take the next 4 minutes to talk to you about. And it's essentially centers around 3 or 4 principles that the company runs on today. The first one is business outcome and not tech spec, right? We think too many robotics companies focus on the tech spec of their product and kind of forget the problem they're trying to solve on the other end for the customer. And, I know that's a kind of aggressive statement, but at the moment, how that's manifested in Automata has been changing quite a lot. The first thing we've done there, which is a very common attitude today in the market, which is we try to bring a robot and software platform to the market at an order of magnitude cheaper than anything else out there. So we brought EVA and Choreograph, our hardware and software platform, to the market in Easter 2019 for around 7,900 British pounds, let's say 8,000 British pounds. So a third of the price of your standard collaborative robot. And what we did there is we designed a purpose-built gearbox. So we spent 3.5 years of mechanical engineering time to design a gearbox that we can completely control. And that's by becoming a kind of vertically integrated robotics player rather than going to the market and just sourcing supply, putting it together and being subservient to the price point in the market, specifically that of the harmonic drive, which 99.9% of cobots use this technology today. And what we've had to give up there is certain performance metrics. But again, we didn't care too much because we felt that the market was massive for the spec we were putting out, and that's bared out over the last 2 years. And also this idea of rapidly changing the economics of robotics through this price point, but also through driving a new consumer behavior of the consumerization of industrial hardware, right? Stop thinking about a robot as something you buy that you keep for 10 years, right? Any of the other speakers today will let you know that 2 years, everything changes in a lot of things, right? So we've been on the market for 2 years already, and we're starting to see a major cohort of our customers come back for their 2-year upgrade. The second is to make software simple. I won't talk too much about this. A lot of people are doing a great job in this space, and we are doing that as well, trying to make automation as simple as possible. And if you read this interview with one of our first customers, he talks about how arrival of the box to the robot being up and running was 2 hours and the programming was just 10 minutes, right? So thinking of robotics as an onboarding problem and how we make that deployment experience as simple and as painless as possible. And finally, around 30% of our robots today are online. We've pushed this attitude out since January 2021, and we've had rapid adoption in our cohort base, which allows us to do customer success and support in a way more proactive way than we previously were able to do. The second thing is this idea of total automation, not robot provider. And I'll breeze through this very quickly. It's this idea that we recognize as a business that we're no longer happy thinking of ourselves as a cobot manufacturer. Because what that means is, think of it this way, you can make Netflix as painless as an experience as possible, but if the experience of owning a TV, owning a remote control, using that remote control is horrible, people are not going to use Netflix. And that's the case with collaborative robotics and automation today. We see people deploying 1 or 2 robots in a factory, taking forever to deploy it because the ecosystem around it is horrendous, even though the cobot is super easy to use. And I think for us, it just became a huge point of dissatisfaction to just sit back and say, we're okay with that picture. And how that's changed the company is, A, we decided to focus. So we're no longer a cobot manufacturer who just serves tons of industries. We're an automation company that focuses only on a couple. I'll talk to you today about lab automation. It's been our fastest growing market in the last year and a half. It's now 80% of our revenue, specifically the pathology, diagnostics, and TIC space. The next is use case focus. We just don't sell into that market. We identify bottlenecks in the market and automate complete solutions around them. So for example, things like automated genome sequencing, sample reformatting, and the automation of something called the ELISA protein process is something we've been doing a lot of in the last 6-7 months. The other is solution focus. This is the idea of like, look, we're not a cobot manufacturer. Us and our partners can provide complete automation solutions. And the thing I'd like to say here is we've also decided that we're no longer happy moving at the pace that the system integration ecosystem places on us, which is incredibly slow. They don't lift a finger till a lot of things are certain. So we've built a massive forward deployment team here at Automata to start to deploy projects for our customers end to end, not just the cobot. And finally, it all culminates in this idea of impatient automation, right? That we believe the technology and automation deserves better than what's available on the market today as an ecosystem. And that's what we're really trying to change. We're nowhere close, but we're starting to make changes. And what this ultimately culminates in is this concept of automation at scale. That's what I truly care about now at Automata, is that I don't want to put 1 or 2 robots in a factory. Our staff doesn't care about that either. We're not really changing anything. You know, if you're a software company of 1,000 people and 5 people use Slack, who really cares, right? And this is what we do here at Automata. To give you an example of what's more and more happening these days inside the company is projects like this. So for example, this is a project we're doing for the Department of Health and Social Care, where we deployed 40 robots in a single laboratory. We think it's the largest deployment of robot arms in a lab space in the UK. And we did it in 4 months. And we are now not just the robot arm provider to this project, we provide the entire process flow with our partners. And we've already run a huge amount of tests to date and potentially scaling this to other sites in the United Kingdom and globally. So sorry if I overran my time, Thomas, but yeah, that's what we do at Automata. It's this idea of like cobots are a technology in search of a market. I think more of us should move towards thinking of ourselves as automation providers, really double down on a select few problems and focus our technological prowess there. And think of it as automation transforming industries at scale is the right thing to do. Thank you.
Okay, thank you, Mustafa. Yeah, you did run over a bit. I was almost pulling down my red cover. But anyway, quickly over to Joe Tidball from Rovco.
Hi, can you hear me coming through okay? Thanks, Thomas, for the introduction. Yeah, so I'm Joe Tidball, Innovation Manager at Rovco Group. So you'll see a couple of names through this presentation, Rovco and powered by VAST. So Rovco is an offshore operator in terms of running robotic platforms, traditionally ROVs, AUVs, and vessels. VAST is a technology enabler for us. So Rovco goes out and does work with robots. VAST develops technology for those robots, deployable subsea, but equally in a wide other spheres as well. So with that said, from an offshore perspective, what does that look like traditionally? Well, it's fairly big boats, 100 meters plus, plenty of people, 50 or 60 people on board. And what you're actually trying to do is use a robot which hasn't really changed since the 70s to collect maybe just video data of an asset that's subsea. So you see the kind of scale of the vessel there and the amount of people that are on board. It's very expensive. The data isn't very good, and there's a lot of manual data analysis that's needed to get, not a lot, to be fair. It could be difficult conditions. It's not particularly nice out there necessarily, unless you're got a nice boat and platform, but it can be quite dangerous. So what's required to change something that's been the same for 40 years plus? You need a big step change, and that's done through automation and robotics and machine learning and all the kind of, I suppose, buzzwords that are out there just now. But what you're looking to try and do is allow the robots to perceive their space more effectively, so actually give them an idea of where they are, understand what they're seeing in that environment, whether that's something that's within specification or isn't, and allow the robot then to make the decision as to whether they need to collect more data in that spot or they can move on. That's then packaged up, sent through very low bandwidth data links acoustically through the water column from either autonomous platform or ROV back to the vessel, and then back to the cloud, where it can then be analyzed onshore. So by doing that, instead of having 50 to 60 people just to put one robot in the water, suddenly you can reduce your crew down to the minimum required to maintain the vehicle and the vessel, make sure all the systems are operational. So take that 50, 60 man team down to 5 or 6, reduce the size of the vessel, and make operations far more efficient and far less carbon intensive. So in terms of where we're doing this work, we've worked on 50% of the offshore wind farms in the UK already, and that's constantly growing, saving our customers money already with the technology that's out there, and already making fairly big dents in CO2 production. So how do we do that? Well, technology, and the basis of that is Subslam X2. I can talk about it all day, so I won't, but it's a stereo vision system that enables live 3D reconstructions, simultaneous video acquisition, autonomous for close range maneuvering and decision making, and machine learning as well, going on to that kind of what's out of perception. We need to do something with that data. So this is an example of the autonomy platform, but it succinctly shows everything that Subslam's doing. So you can see the top right, it's collecting video data that, if you have a tether, can go back to the operator, not necessary in an autonomy space. You can see the points being pulled out of that image. That is what the system is using for the positioning of the robot. And then it's using that knowledge of where it is in the environment through a SLAM-based solution to position the robot in that area. You can see from the map at the bottom, it knows the areas where it hasn't received data and it needs to gather some new data. So it's then making the decision of where it needs to go next, fly into that position, increasing its map before it does the same process again and moves across. So from an exploration use case, the robot is able to go into an environment it's never seen before, gather data that's usable to an end user, and safely navigate that scene on its own. So moving on from that, you've got the position, you've got the map building, you've got an understanding of where it needs to go next. But this is kind of the key bit now, is the machine learning side of things. So when it finds a feature on an asset, so what we're looking at here are some of the features on a monopile of a wind turbine, it knows what it's seeing. So it detects that it's found the cable entry, it detects a water replenishment hole, it detects an anode, and it knows what to do then from that point. So if it determines that the marine growth is at an acceptable level, it's happy, it moves on. If it's not happy, it will take some more imagery, some more data, package that up, and let the user know that they have a potential issue. It goes back to the kind of idea of, if you can make it easier to do these inspections, you will do them more regularly, you'll spot an issue more quickly, and therefore you're lowering the cost of the maintenance of these assets over time. So with that in mind, it's all very well doing it on a small scale, but actually what we intend to do is build the full 3D reconstruction of a wind farm. So you need the seabed, you need the monopile structures or the jackets and the cables and everything built together. So who doesn't like a big Subslam map? So this is Subslam running. I think this is a 2-hour dive time, something like this, sped up into 90 seconds. So you can see the kind of scale of this building up. So we start off with a wreck that's about 15 meters long. You can see that we then start following some of the lake bed across to another feature and start building that up. And I draw your attention to the top right-hand corner. You'll see a little box flash up that says loop closure. You might not see it because it's quite quick, but essentially the system is able to recognize where it's been in the scene previously. And based on that, it can readjust all of the error through that scene to project the map far more accurately than it has before. So there's quite a good one here. It's going around a helicopter fuselage just now, and then it will trace back up towards what's a wheelhouse. And you'll see there was some alignment or misalignment in the model. When it reaches the wheelhouse, recognizes where it's been before, it readjusts. So what's this for? Well, this is robotics as a service. It's hardware as a service. It's software as a service. Rovco, as I've said, packages this all together and delivers this to clients, so the likes of renewable operators. Vast allows other parties to leverage this technology on their own platforms. So platform agnostic solutions for positioning, machine learning, object detection, and beyond. So hopefully I've stuck to time there, and that's from Rovco. Any questions, let me know in the chat.
Great, thanks, Joe. And as a good reminder there, you finished with, so we have a Q&A tab that attendees can post any questions on throughout the webinar, and the panelists can answer those, but we'll also take a few questions at the end. So with that, we jump over to Jihan from Twin Science and Robotics.
So hello everyone, I think my screen is visible now. This is Jihan from Twin Science and Robotics. I am responsible from content development and one of the co-founders of Twin Science. Twin is an education technologies company, and we are focused on cultivating next generation double wing leaders of tomorrow. And our market is edtech, and as most of you can imagine, the market size is growing, and everyone expects to experts expect to see this market will be growing with an accelerating rate. And the future will be actually the problems of the future will be solved by using the technologies of the future. So that's why we are trying to introduce technologies of future with children today, so that they will be able to use these tools effectively. And also, like, problem solving skills are important, but another important thing is problem choosing. I see all of you gathered around here, and all companies have great products, but more than products, you have a story behind those ideas. So the story in here is to do some good for the needs of the people, for the needs of the world. So that's why we focused on double-winged approach in our education, science education. So we also introduce universal values to children. Actually, Twin was born from a non-governmental organization, so it has a very strange story. But when I was working as a volunteer in YGA in Turkey in 2010, we were organizing science workshops all around Turkey, and for 7 years we have worked with more than 20,000 children and collected insights. And after that, we came up with our Science Kit product, and also with the collected content, we want to spread this content to more disadvantaged echelons of the society, and that's why we organized a TV show in CNN Türk channel. And that's when we realized that the product that we have developed actually is a very powerful tool for children to introduce future technologies with universal values. And from in 2017, we spin-offed and established Twin Science and Robotics, and until then we have raised more than $2.5 million as seed round. So what is different about our approach to education? It is double-winged, meaning that it has both conscience and competency. So you cannot fly with the one wing. And when we learn from the visionary educators of today, like people in our advisory board, they always points out that the new way of education should be inclusive, should be personalized, should be skill-based, and traditional education system is not capable of actually doing this. So that's why we have integrated digital and physical products. So we have both physical and digital products, and years of experience are being digitalized right now, because we see that COVID is changing everything, and using the power of digital, especially when children are there, is very essential. And by using digital interactive learning resources, we motivate children to use Twin Science Kit as well. So this is an integrated hybrid business model, and it's an end-to-end solution if you want to introduce robotics, coding, especially AI, to kids. So we have developed lots of electronic components and focusing on these technologies. These are the products that we have developed for retail businesses. The good thing in here is they have different electronic modules in here, as you can see. They snap together with the help of magnets, so no soldering required. It's a safe tool, and it is Lego compatible, so children can build their robots, and by using the coding platform we have, mobile applications, they can actually program their own robot. So, and also we have a Twin mobile application. So the idea in here, we are tagging all the content that is available in the application so that we are tracking children's interest. And also we present a reporting system to teachers and parents so that they are able to see the interest area of children, the skills that children has, and the development throughout the time. And we are focusing STEM and also including art inside of the activities. So there are lots of different activities that children can do at their home, but there are also the interactive videos and mini games that explains the science behind the technological tools they are using. And the future, we are going for a platform, and right now we are using our original content and Twin kits, but we want to include other product developers and content developers all around the world. And until now, we have worked with several educational institutions, and we have worked with some multinational companies for business development and for their CSR projects. We have developed a kit with Rolls-Royce, Ford Otosan, and Boeing, autonomous vehicle kit with Ford, Turkey, aviation kit with Boeing, and STEM kit with Rolls-Royce. So involvement of these strategical companies help us a lot, especially to reach more children around the world. So Twin was born from a social responsibility project at the end, and with our impact program, World Science Movement, Twin continues to actually do so. So until now, we have reached more than 360,000 children throughout the world, and this number will continue to grow. And we are getting ready for Series A investment in December. So if you have any questions or want to get in touch, you can email me.
Okay.
Thanks for listening.
Thanks, Jihan, for that. With that, we jump straight over to Rich from Shadow Robot. You okay there, Rich? We can't hear you.
Yes, sorry, I've done the usual mute problem. Thank you very much. So we've been building robotics for long enough that I should know how to unmute myself. Since 1997. We have partners all over the world. We're very, very advanced in terms of what we do. We work with a lot of people who are looking at key challenges for how to get robots to do things and try and solve them. Most recently, in the last 2 or 3 years, we've been working very hard on Tele-robotics. If you can see the person there with the blindfold, that's not a VR headset, that's actually a blindfold. They can't see what they're doing with the robot hand, but when they feel the thumb touch the ball, then they can close on the hand. So that's linking sensing and actuation at a distance. And this is some work that we originally did with the Japanese airline ANA, who are looking at ways to move beyond travel, because the idea that you don't have to be somewhere to go there is kind of really interesting to an airline in a fiercely competitive market. Of course, once you can do touch at a distance, then you can start to put robot technology anywhere. So here we did a piece of work for a demonstration for Wired magazine, where we put our robot in London and the glove in San Francisco and controlled it over a 4G network. So there we've got some kind of really nice advanced technology letting us put a human-like manipulator in a remote location. The glove provides a sense of touch. That's actually from an American partner. And the fingertips of the robot give us the sense of touch from the tactile sensing. And this is something that we're now looking at applications in multiple areas. Teleporting skills, putting your capabilities somewhere else. 3-4 years ago, that was something everyone would have said, oh, you can't do that, that's crazy. Of course, in the last 2 years, we've all become very, very used to trying to do things remotely. This lets us put a sense of touch remotely, not just in a dangerous or inaccessible environment. So we've done a lot of sort of early stage work looking at applications in nuclear. On the left there, you can see a standard demonstration of sweeping up some bits and pieces that have come out of a process that need to be cleaned up and you can't touch with a human. You can see that Joanna, the operator there, is wearing a glove that's tracking a hand movement. She's got a foot pedal to turn the system off and on so she can disengage and engage with that. And she can do a wide range of sort of quite dexterous tasks. On the right is some work that comes out of a project that we're doing with a pharma manufacturer, one of their Belgian facilities, looking at some simple tasks. Again, you can automate pipetting, absolutely, but when you have a line of tasks to do, you only automate one of them at a time. So here we're looking at being able to do flexible tasks that currently are done by humans, putting their hands through glove ports, putting their hands into machinery. We're also looking at other applications for remote technology. I don't know if you've ever stood on the phone and told someone, maybe plug it into the second one. I don't know. All right, try the third one. But you can imagine that being able to be hands-on with the robot there and actually put the connector in yourself directly could save you a lot of time, effort, and energy. And we've even had the odd billionaire work with us, or now multi-billionaire, trillionaire. We're not working with Amazon on this kind of technology, but this is something that we're working with some large American companies about at the moment. So yeah, this is a system. It's available today. We're an engineering company, so we make and sell these. We don't have the royal warrant, sadly. As far as I'm aware, the Queen does not yet have any robots in her stockpile anywhere. We do have the Queen's Award for Enterprise, which we're very proud of. I know we're short on time, so I'll stop there. Thank you, Thomas. Over to our next speaker.
Much appreciated, Rich. Very interesting solution that you have there. With that, we'll jump over to Ben Scott Robinson at Small Robot Company.
Hi there. With me 1 second. Okay. So very, very different world, I suppose. I'm working in the world of farming. And Small Robot Company, we have quite a strong mission. It's about helping farmers of the world's largest crops feed the world while regenerating the planet. Cereal farmers ultimately are in trouble. They've got a system that they use to produce the world's largest crop, but it's getting more and more expensive while yields and revenues have flatlined. And at the same time, that system is also destroying soils and ecosystems and is massively vulnerable to climate change. So what we are proposing, what we are developing is not an evolution. To do what we're trying to do per plant farming, you have to design essentially a complete service from the ground up. To make it work with millions of crop plants per field requires a radically different approach to that of the standard sort of robotic systems that you see. But ultimately, the results will make the tractor as redundant as the tractor made the horse. And in a stable market, you know, increasing yields and decreasing revenues that we allow makes financial sense. But farmland is degrading. Weather patterns are unstable and yields are being wiped out by floods or droughts as fire, if you pay any attention to the production of wheat or corn over the last couple of years, you'll see. And the way that government subsidies or insurance are working is changing, both in the UK and the EU and the US and Canada, and they're changing to support a system which is more carbon positive and more sustainable. So if you add these together, there's a very strong opportunity for farmers to make a significant improvement per hectare on what they would currently be producing. So what's per plant farming? Well, other farming robotics essentially looks to just automate existing processes. We have taken a step beyond that to really try and explore what the potential is. So we are delivering per plant farming. And this approach allows for lightweight autonomous vehicles to provide a near real-time view of each crop plant as it grows throughout the season, and then deliver precise and timely interventions to make that plant achieve its full potential. And by doing this, we can strip out all the inefficiencies and vast overuse of chemicals and allow soils to generate themselves. So this can save 95% of inputs, increase yields, and also locks carbon into the soil. But to do this ultimately is not about automating an individual process, right? It's significantly more complicated than that. It is a new model of farming, and with it, really a new way of providing what farmers need. So we have developed a service that looks after a crop throughout its entire life. And to do that, we're using a suite of robots to deliver it. And so may I introduce Vic and Harry and Wilma. So Tom lives on the farm, continuously gathering data on the plants and the environment. Wilma is the brains of the operation, converting Tom's data into instructions for Dick and Harry. Dick nurtures and protects the crop. He kills weeds individually using electricity and sprays only the plants that need it. And Harry precisely plants the crop at exactly the right depth and the right spacing, giving it the best chance of the highest yields. And farmers don't buy the robots. As you've heard a few people talking about already, ultimately we provide farming as a service. We allow our farmers to pay per hectare for that. And ultimately what they're paying for is the delivery of a healthy crop. Now, we know all too well from our experience that delivering one robot that works reliably in all conditions is tough, but delivering 3 is a huge undertaking. Hence, we've created a modular architecture that works across all our robots and allows the reuse of standardized components. So we've already solved the hard problems first, the steering and the power and the control and suspension, as well as autonomy, localization, awareness, and electronics. And by doing this, we've de-risked all the future work into the relatively simple task of chassis design and then bolting on known components. And thanks to our really unique per plant view of what happens in the field, we've developed our robots to deliver to the realities of a field. So weeds and pests and disease are not uniformly spread. So we've designed, for example, a weeding system that's not tied to tediously following rows like a tractor, but can delicately traverse the field to get to the areas where they're needed. So our pride and joy is Tom. Tom is a 3rd generation robot designed to our final sort of service requirements. He's incredibly light, just over 200 kilos, and designed to cover a rough field, acting as a stable platform. He puts as much pressure on the ground as a 1/3 of your foot. So is incredibly good at avoiding damaging crops or soil or stuff like this. And we've partnered with the UK's leading robotics manufacturer, Tharsis, to allow us to build Tom to a production spec. And Tom's capacity to gather plant data is so unique that as soon as we announced Tom about 3 months ago, we've been approached by 5 of the top seed and chemical companies in the world, each one a multi-billion-pound company in its own right, to help automate their research and product development in field. But our first service to farmers is very tightly focused. So we're providing an electric weeding service that kills individual weeds as they emerge to sign up customers that are either organic or using a zero-till farming, which is a soil-preserving farming technique. But this is only part of the story, really. So by understanding each plant in the field, we can bring a level of subtlety and anciousness that is unheard of. On one side, we know that only 40% of the weeds in the field need to be completely eradicated. 20% can be thinned and 40% are even neutral or beneficial to the crop plants. And so we only take the ones out that need to be taken out. And uniquely, we can take out worst, which is blackgrass, and we can detect that at emergence. And by doing that, we solve a £450 million problem in the UK. So my business partner, Sam, is a farmer, and we've designed our service alongside farmers. In fact, when we first started, we spent 6 months on the road speaking to farmers to find out where their pain points were and design our service to fit that. So the farmers that we're engaged with are completely engaged. We have 600 who've invested in us. We've had nearly 150 who've signed EOIs and 35 who have not only prepaid for our service, but are actively supporting what we're doing as we move forward. Now, to make this, as you're all aware, you need quite a substantial team from some very cool places. So we've got people from Dyson and DeepMind and JCB, IBM, Virgin Galactic, all helping us pull this together and make it happen. So there are lots of people ultimately that are building robots for farming, but we are the only people who are bringing per plant farming to the world's largest crops. Thank you very much.
Excellent, Ben. That sounds really, really interesting, an exciting journey that you've started on, especially with the interest that you received. With that, we jump over to Owen at SLAMcore.
Thanks so much, Tom. That should be coming through. Let me just jump to present mode. Okay, so thumbs up. Good stuff. Cool. Awesome. Well, thanks a lot for the invite today, and it's great to present alongside so many great companies. I think there's something really special going on in the UK at the moment within the robotics scene. So thanks for supporting that, Tom. So my name's Owen. I'm the CEO at SLAMcore. I'll be closing out today. I call it headlining. So over the last few weeks, I've been playing with this toy here. It's the Facebook Oculus.
Sorry to interrupt, Owen. We can see your notes and not the screen.
Oh, well, you don't want to see that. Can you see the screen now?
That's better, thanks.
Okay, there we go. I shared the window, but never, obviously Zoom wants to see that. I'll do it without notes. Let's see how we get on. So I've been playing with this toy for the last few weeks. It's the Facebook's Oculus Quest 2. So I use the word toy very lightly because it really is an impressive bit of kit. It's able to track the position of my head no matter where I am in the room, even when I'm running around like a maniac trying to escape the zombies. And this thing costs $400. It's using consumer grade electronics. And as for its localization system, it's just using 4 cameras and an inertial sensor unit. Now, the Microsoft HoloLens, another similar type of product, is also available today. A little bit more pricey, but ultimately uses the same type of sensor technology. It's deployed in industrial warehouses and manufacturing plants and is achieving great performance for Microsoft. And my question really is, it's clearly possible to achieve the level of performance you need with consumer grade electronics. So why is it that most of the robotic applications out there are using sensors and solutions which cost a vast amount more? With the exception of maybe iRobot and Dyson, there are very few companies on the planet who've managed to take vision and integrate it into their autonomy stack as the main sensing modality. And that's really what's holding back a lot of scalable, low-cost robotics. And the challenge is really because those companies are vast. They have very deep pockets. HoloLens cost more than the Mars rover mission to build. And it's just the sort of thing that most companies are not able to put the time, energy, and resource to do at scale. And that's where SLAMcore really have come in. We are founded from some of the absolute world leaders in this space. We were founded 5 years ago. Professor Davison is one of the most cited professors in the world in visual SLAM. And we've grown the team over the last 5 years to 33 staff from some of the top companies around the planet. We have investors, incredible investors backing us right now. And we are in a high growth phase, really looking to take our product to market. Now, the key stats just to take home, we launched our software about at the start of the year. We already have 100 companies using it today. 10 have moved into active POCs with deployments planned in the next few months. I can't share the names, but they're all names you'd recognize. And we're really excited to be able to start talking about that more publicly. We have well over 200 kilometers of user tester data right now, and well over a megameter of internal testing that's done. So this system really has been tested. Now, our software is an SDK in the truest sense of the word. It's not a bunch of algorithms which we come in and help you integrate. It's a toolkit which developers can use and plug into their existing autonomy stack. We need as an input 2 cameras and an IMU, hardware synchronized, but then we translate that data into spatial information for the robot. So we start with positioning, it's your 6 degrees of freedom pose estimation. Then we have mapping, the geometry and the space around the robot. And then we have our perception engine, which does object categorization, instant segmentation, and positioning within the same spatial reference frame. All of this information is then provided through our API and plugged straight into the existing stacks through ROS 1, ROS 2, or a C++ API, so that you can reliably get your robot from A to B and get on with all the other things that you need to do as a robotic developer. We have a public SDK, which is available today. It works out of the box. If you have this hardware, you can install it within 30 seconds. We've limited it to just the RealSense D435i and the D455, and for a computer, laptop, or a Jetson, NVIDIA Jetson single board computer. That's not because we can't run on others, but we just want to make sure that experience works straight out of the box. We have builds for Raspberry Pis, Qualcomm Snapdragons, and various other sensors on the market. But if you want that, then come talk to me. We can talk about a bespoke project. We will make those available through the public SDK, but we're a startup with engineering resources, so you'll have to wait for that for now. What we provide to you and ultimately to your robot is 3 types of commercial grade positioning. So if you want just odometry, visual and inertial odometry, that's available. You can set that. We also provide SLAM positioning, where you can build a 3D point cloud of a space up to the scale of a large warehouse. And this will allow a robot to go into a space it's never been before, localize and build that map in real time, all running on very low cost, low power hardware. We can also provide you with the ability to export that map and share it across the fleet. So this now allows you to have hundreds of robots all localizing within the same spatial reference frame. Using the same sensor feed, so this is just using the RealSense data, we're able to also add depth information to that, creating a 2.5D map. This is available today, and this can then be used to create an occupancy map for global path planning and local obstacle avoidance. This is an extremely efficient way of storing spatial information. So we can map a very large warehouse with just a few hundred megabytes. This is all in real time, able to be processed on just a couple of cores of an ARM CPU. As I say, it's not just our algorithms, they're tools to allow you to get the best out of the system, because there is one thing we can guarantee you: there's no one software solution that fits every single application. So we provide the tools to allow the user to actually get the best out of the system. So there's a bunch of presets: indoor, outdoor, warehouse, drone, lawnmower. Use the presets to get a feel and then go in and start to edit them yourself. You can toggle ground plane detection and to give you, if you know that your robot's never going to leave a certain plane. And if you have wheel odometry available, that can be easily integrated through the ROS stack and later on through C++ if you so wish, to give you absolutely bulletproof visual, inertial, kinematic localization and mapping. We're ultimately a software company. We make our money by licensing per robot. So therefore we need scale. We provide an edge software, but we have to think like your kind of more cloud kind of company. And we also it's a B2B product ultimately for the enterprise, but we need to think like a B2C company. So you can access the software through our online portal, download it, and it's super simple. Register the cameras through the online dashboard and access all of the standard tools, documentation, and ability to raise support requests, just like you'd expect from any good SaaS product. And this is really the slide that sells it. It's without a doubt, and I can guarantee you this, I'm happy to argue the toss on this, we are providing the best visual SLAM system available on the commercial market today. When it comes to any metric which really matters, which is positioning, reliability, and memory and CPU load, we win against everything. Obviously, this is open source, so it's not really a fair comparison, but you can use this as a proxy. We've benchmarked this against commercial grade systems, and we are providing the best system on the planet today. You can go and ask Facebook if you can license their algorithms. I can guarantee you I know what they'll say. So as far as commercially available systems, please come talk to us. Just a quick, I'll do this quickly just to see what's coming down the line in later this year. We also are providing a 3D voxel-based scanning solution. This allows you to build 3D models of the space, again, using a couple of cores on the CPU, all real time, all using exactly the same hardware that I just mentioned. This is great for building nice reconstructions of your space, which can be shared with humans to see where your robot is, but also there's an application within digital scanning and twinning, digital twins. And we have an extensive deep learning team also looking to enhance the performance of the core system by analyzing the visual information, extracting object information, rejecting features which are detected on things that move, and allowing you to label the voxels in real time, selecting if you want to remove the person there, you see it moving just with a click of a button, remove walls, ceilings, and ultimately just make sure that you don't have to spend those hours tidying up your maps, which I know we all have had to do in the past. It's a simple model. go to our website with a credit card if you want to use it, and type in your details, you have access. If you want an enterprise solution, then come talk to me. We provide a scalable tier pricing, but that's not something I'm able to publicly talk about today. So really, please reach out. I'm Owen at SLAMcore.com if you want to go direct to me, or go straight to a contact at SLAMcore.com, head to the website and request access. I'll get you on board as soon as we possibly can.
Excellent, thanks for that, Owen. We actually have one more presentation from BotsAndUs, and that's from Aileen. Over to you.
Hey.
So just as a quick note before you start, Aileen, if the attendees could think of a few questions that you want to ask our highly professional and expert panel during this presentation, that'd be great as well, and we'll try to ask all panelists after this presentation. Over to you, Aileen.
Well, good afternoon, everyone. I promise to keep it short, or as short as possible. My name is Aileen Yassin, and I lead business development at BotsAndUs. We're a startup from London building robotics and AI solutions for dynamic spaces. And this really just means that our robots can be deployed in pretty much any large, crowded space where customer service or a real-time view on operations is required. Oh, I'm not sure my slides are moving. So yeah, our robots are fully autonomous, safe, and reliable. We've made sure they can navigate seamlessly in crowded spaces where people or machinery move in an unfashioned way. So this type of space can range from an airport terminal, a retail store, to a museum or a dynamic warehouse. Our customer service robots run state-of-the-art interaction algorithms for human-to-robots communication, especially in understanding dialogue in noisy environments, or how interaction flows kind of change when groups of people interact with the robots. We've built a fleet intelligence infrastructure that allows our robots to communicate and collaborate on tasks, as well as learn from each other. Real-time access to operations insights is channeled through our data capturing tools built on our robotics platform. And now, well, our robots. From the beginning, we kind of tried to keep a modular approach in our thinking and also our technology. And this kind of helped us to respond to customer demand quickly, and will hopefully help us to expand to new markets and new use cases in the future. So here's our current fleet of fully autonomous robots. On the left, there is MIM, who's our operations robot that's been successfully deployed in the retail industry so far with some of Europe's biggest brands, the likes of MediaMarkt, Saturn in Germany. It gives real-time, unprecedented access to accurate and relevant data. It pretty much fits into any environment where real-time tracking of goods is imperative to efficient operations. So as I mentioned earlier, it could be in a retail store, or it's back of the house, or a cargo warehouse. Bo is our customer service module, and it's also our first robot launched more than 3 years ago. Its use cases have been validated in the travel industry by the likes of British Airways, Heathrow Airports, or Automata. And it assists and serves customers in a seamless way by responding to their requests or simply taking them to different locations around the site where it's being deployed. And lastly, we have the base, on top of which the mission-specific modules are added, and which is also a robot of its own, able to carry and move assets around sites with no intervention from anyone in the space. It was designed to be part of a fleet and work in conjunction with multiple robots in a shared space. This has been a very brief presentation because I tried to keep to the timing. So if you do have any questions, we're more than happy to answer any questions you may have or want to listen to any more details on our technology. We're very proud to be at the forefront of British robotics. And yeah, thank you.
Excellent, thanks for that, Aileen. So I will just now over to a few questions if we have. So first of all, I would like to mention, of course, that TLA Robotics, we organize quite a few events every year, and our next event or webinar will actually be on farm and agriculture robotics that you can register for You can see that down in the left-hand corner, if I'm not wrong, on your screen. And with that, we'll try to get a few questions done. If I can ask a question from my point of view, perhaps from Andrew at Foresight, perhaps starting with you, how you view the UK robotics sector in terms of its, I'll say, health, growth, if
I think there's some really exciting things going on. I think it was Owen towards the end that said that that's what he believes. With really exciting developments, lots of young companies coming through, not enough investors with an interest in hard tech. So we're looking for more investors to join us, because I think it's a really exciting time, and think really good opportunities ahead.
Yes, it's what I've seen as well. Hardware investment is really tough. Perhaps we could get some of the panelists to talk a bit about their fundraising journey, especially perhaps Ben, you could give some view on that, or even Rich or Joe.
Yeah, absolutely. Sorry, my internet connection isn't great. Can you hear me okay?
Yeah, we can hear you okay.
Okay, so from our perspective, we have worked with the crowd. So we have had 3 crowdfunding rounds. We're very lucky that I think our message has really resonated both with farmers. So say over 600 farmers invested in us, the majority of the money's come from them, but also with a sort of intersection, I suppose, between sort of technology and environmental sort of interests. So that's been good. We've also had investment from deep tech VC as well, but it's definitely hard. I think that there's a huge barrier to overcome when you're sort of moving from prototype into something which is sort of commercially capable, and there are lots of challenges if you're trying to solve more than one problem, I suppose. So I agree with what Andrew said. There aren't enough people who are willing to take on board the hard challenges until all the problems are solved. So we've had to find ways of doing that and solving those problems, or as many of those problems as we can, before going out to corporate investors.
Interesting. Mustafa, have you got any view on that? Automata is probably one of the better known, better funded companies.
Well, yeah, I guess we are. I totally agree with Ben. It is difficult. I would say it has a normal evolution story of any other startup, to be honest, except that we have this extra stage added to our requirements, which is to prove hardware maturity. Right? Once you prove hardware maturity, or on the journey of proving hardware maturity, which is, I think, the pain point that is discussed in these forums the most, because most startups are in that journey in hardware. They're in the seed stage. So they're still like being asked to prove the stability of their product. And look, Automata went through that for a long time. But once you graduate from that, you kind of are met with the whole product market fit question, the scale question, can you hire an effective management team question, all of these standard questions that are raised to any other startup. So, that's kind of how I made my peace with it, right? That in a sense, it's just this extra question being asked about, is your product stable? Can you manufacture it at scale? Today, can you handle the semiconductor crisis? But apart from that, we have to answer any of the same questions that are asked of any company seeking funding.
So Matthew at Ocado, any chance we can get some view from Ocado? I don't want to put you on the spot here, but obviously Ocado has done quite a few investments in companies, and quite recently in Oxbotica in the UK as well.
Yeah, I suppose, like say, we like most companies we were fortunate of a size where we had the capital available to us to go out and acquire ourselves. We've been on an incredible growth journey. Getting speed to market is really important for us as we try and commercialize and bring out new robotic solutions. We can't take 3 or 5 years to these days kind of develop something and get it out there to market, because someone else will come and kind of leapfrog us or get there first. So we've been really conscious about speed to market, which is why when kind of faced with the choice of further investment internally or going out and partnering with other companies or acquiring other companies, we kind of gone the route of starting to make some investments. So like I said, Kindred and Haddington had developed some great products in parallel to us. We found real synergies with what they were doing, with what we were trying to achieve. Those guys were excited to come on our journey of automating grocery fulfillment. So kind of acquisitions there made kind of perfect sense. And then the Octobotica one is much more of a partnership. We've taken a minority stake there. They are developing an automation suite of software, actually much like SLAMcore actually are doing as well. And they have applications much broader than what we have in Ocado. So it wouldn't make sense for us to go and acquire them, but partnering with them and getting an investment means we can get a player at that table, get some access to their software and kind of kickstart our ventures into that kind of robotic space also.
Interesting. So Owen has raised your hand there.
Yeah, just to maybe more on some observations to the funding landscape at the moment, because just before just as the pandemic hit last year, I wrote an open letter to the robotics, and it got picked up by quite a few of the robotics press, essentially saying, it's directed at the investors and the large companies, saying, don't let the robotics industry die during this because it's going to be hard for us. And it got a lot of traction, and actually, it was hard. We were very lucky. We closed funding. We've had 12 million in funding in total, but we had funding to go, and we actually decided to go faster than we would have because we felt there was an opportunity. But I know a lot of hard decisions had to be made by robotics companies. It feels like something's happening this side of Christmas and in this year, that the capital's starting to become available, and it seems like a really good time for robotics companies to start moving. But we have to move quickly, and we have to really capitalize on this opportunity, because I think there's real demand now as companies come out from the other side of this, looking to automate, looking to use more of this technology. So I'll be going out to raise in the next 12 months for a very big number. My challenge is to get into Forbes and FT coverage. That's the scale we need to be thinking at, because yeah, we've only really scratched the surface, I believe.
We're hoping we can help with some of that coverage. Do our little bit anyway. With that, I don't think there are any. There are loads of specific questions, more about like high performance FPGA. Can I recommend everyone who's asked really specific questions that you reach out to the panelist? If you can't reach the panelists themselves, please email us at TLA, and we will put you in contact with the panelists as well. So with that, I want to thank all our panelists who've given up their free time to present their goods. This webinar will be available as a recording in a couple of days on our YouTube channel. So thanks a lot, everyone, and have a really good evening now.
Thank you.
Thank you.
Thanks, Tom. Thank you all.